This moment establishes BelAZ as a symbol of extreme duty engineering, designed not for roads, but for...
Shows significant strength. The heat map shows on the rear axle layout.
The reinforced frame on the M7 configuration handles the torque significantly better.
And the hitch system?
Rated for the new quarry loads.
We are simulating extreme resistance now, over 300 tons.
The color codes are peaking, but the structure is completely sound.
The reinforcement around the axle mounts looks solid.
The simulation shows we've successfully mitigated the high-stress areas.
4,600 horsepower requires flawless fuel delivery.
And the cooling loop redundancy ensures we meet the uptime requirement for the BelAZ.
The torque curve is peaking at the third axle. Traction limits holding steady.
We have minor slip on the rear bogie, but the system is compensating well.
The engine module must be integrated before the suspension struts.
That contradict the standard sequence, but the weight distribution demands...
The heat treatment certificate matches the detailed schematic.
Confirmed. The ultrasonic gauge shows the thickness is within tolerance. We are clear to use this batch.
The phase array shows a clean bill here. No indications on the X-ray.
Confirmed. Weld integrity is optimal.
We need to adjust this mounting point slightly before the next module arrives. I agree. The alignment is critical here for the towing forces.
Okay. We need to ensure the load transfer path is completely clear on this side.
The scanner confirms 0 deviation.
Axle mounting sections for the Bell off-road heavy tractor are installed along the chassis. Each mounting point is reinforced.
Hold it there, a little to the left. Interface aligned, confirmed on the schematic.
All right, set the tension, we're good to bolt.
Steering linkages and articulation mechanisms for the BelAZ off-road heavy tractor are installed.
This concludes the chassis and axle assembly phase, preparing the platform for powertrain installation.
The mounting interface measurements are within tolerance.
Good. Let's verify the pressure on the fuel delivery system next.
Verify the synchronization interfaces and redundancy systems.
All parameters stable. Synchronization confirmed.
The alignment on the upper cascade looks good.
Confirmed. The thermal readings are stable within tolerance.
The current algorithm isn't handling the mud consistency well.
I'm optimizing the slip ratio calibration. That should stabilize the pull.
Fuel storage and delivery systems are assembled on the BelAZ off-road heavy tractor. Large capacity.
The pressure reading on the gauge matches the tablet data.
Confirmed. Articulation limits are within tolerance.
A little to the left. Okay, set it down. Got it. Hitting the bolts now.
The dynamic response is stabilizing now. Good. Axle load balance is optimal. We can ease the pressure.
The sidewall looks thin here. What's the gauge say?
It's within tolerance, but I'll make a note of the stress markers.
Check the bead seating right here. Looks good. Pressure's holding steady at 120 psi. We are green. That's the last one. Okay, let's move back.
The static load is balanced perfectly across the axles. We have confirmation from the sensors.
Good. No excessive ground pressure. The design holds.
Look at the data, we're losing stability.
Agreed.
Okay, ease up slightly on the throttle.
Load ratings are nominal across the assembly.
Good. We can sign off on the installation.
The secondary coupling stress looks acceptable on this incline.
Yes, the multi-point system is distributing the load effectively.
The mechanical connection locks into place, engaging the hydraulics. This allows real-time data transfer, sharing.
Maximum load reached. Strain gauges are holding steady.
Confirmed. Hitch forces are nominal. Safe transmission validated.
R5 reports consistent grip across the surface.
Yes, the intelligent management system is clearly optimizing power delivery.
The results are satisfactory. We have full stability control.
Agreed. The data confirms safe operation on the incline.
The camera enters the operator cabin assembly area where the
Verify the interface position. Can you reach the joystick comfortably?
Yes, the adjustments are precise. It should prevent fatigue on long shifts.
Electronic control units for the BelAZ tractor are installed behind protected panels. These systems process. Each connector is labeled and tested to ensure reliable long-term operation.
Fire detection and suppression systems are installed across the BelAZ industrial tractor.
Initiating simulated braking failure sequence. Emergency immobilization confirmed. System response nominal.
How are the chassis welds looking?
All clear on the magnetic particle inspection. No surface flaws detected.
Alignment tolerances are within spec. Pressure approaching peak levels. Check the flow stability on the main strut.
Stability confirmed. Sealing integrity holding strong at 40 megapascals.
Initiating overload sequence on bus 2.
backup system engaged. Redundancy verified.
Here we see the BelAZ undergoing static towing resistance tests. The strain gauges are active, confirming safe force transfer under these extreme pulling loads.
The drivetrain load is stabilizing right within the projected parameters.
Yes, and the suspension response looks optimal on axle 3.
Braking balance is stable, temperature holding steady.
Confirmed. Descent speed is nominal. We have a green light.
The temps on the rear drivetrain are peaking.
I see it. Rerouting power now to compensate. Keep an eye on the suspension telemetry.
Traction control algorithms are holding steady.
Good. Initiating braking response test now.
Неизвестный смысл видимых втрати мільйонних звісті. Пересадміти винесли виходівці в спільної недобрні.
Watch the clearance on the right side.
It's clear. Okay, easy back now, just a few more feet. The suspension is adapting perfectly to the terrain changes.
Confirmed. The traction is consistent, even with a full load.
The BelAZ off-road heavy tractor navigates a wide mining curve while towing the super heavy load.
Parameters are green.
Control, this is platform 2. Stress levels are nominal. Clear to proceed.
Articulation joint data is well within tolerance. The transport was a success.
Confirmed. The diagnostics look perfect across the board.
Drivetrain temperature is holding steady at 95.
Engine synchronization remains optimal.
The diagnostic results are stable. We are good to proceed.
Copy that. Let's finalize the report.
This then. The stress distribution on the chassis remains too high at peak torque.
If we adjust the towing parameters here, we can minimize them.
Ground control to operator, initiating braking protocol. Acknowledge and prepare for stop on my mark.
Acknowledged. Ground control. Ready.
Mark.
As you can see, the sensor data confirms extremely low fatigue levels.
The structural integrity is holding up perfectly under the load. Okay, Route 4 is clear. Watch the gradient at the 3rd terrace. Understood. I'll confirm the drop point before approach.
The new route cuts transit time by 15 minutes.
And the load sequencing is fully optimized now.
The sensor data on the front left bearing is trending high.
We should schedule replacement for the next service window, just as the system predicted.
Although the operating costs are immense, the efficiency per ton proves superior. The lifestyle analysis.
Without the BelAZ, these projects would be impossible. Mega modules and entire power stations depend on its pulling capability.
The structural stress data from the BelAZ is critical here.
Reorganization? Yes, but the new hybrid design distributes the weight far more efficiently.
Look at the power distribution here. We're seeing a 30% gain in efficiency.
That aligns perfectly with the energy recovery schematics.
The data from the redundancy system shows minimal power loss here.
And the structural resilience of the frame under this load is why it's the industry benchmark.
The primary drive has failed as predicted.
And the redundant braking system brought it to a full stop. Excellent work. The BelAZ off-road heavy tractor completes another successful mega transport operation.
The narrative prepares for conclusion, emphasizing that machines like the BelAZ off-road heavy industrial tractor.
The BelAZ platform is not a prototype, but a fully operational industrial solution designed to move the heavy.
Built for extreme conditions, the BelAZ demonstrates unmatched durability, a long-term asset whose value only compounds with time.
Extreme industrial engineering, where scale, power, and control converge, reshaping the world.